Hello everyone. Today we're going to continue with graphing equations that are lines or linear equations. And we've already gone over two ways of graphing linear equations. One way was using the t-table, graphing them, and we're done. The other method was using the two intercepts by plugging in that 0 and getting the 2 points on the x and y axis. Now we're going to go over how to graph without using the t-table when we have equations in slope-intercept form. It's actually a slightly faster way and more efficient way to do it. All right, so let's go ahead and look at our first equation. We have 5x minus 8. This is in slope-intercept form. The reason we call it slope-intercept form is by looking at the equation, we know two things. We know what the slope is, and we know what the y-intercept is. That's where the name comes from. And it has to be in y equals form to get these two numbers or these two values. So that 5 next to the x is called the rate of change, and the 8 without the x next to it is the starting value. In y equals mx plus b, we have a more specific name. The top names were kind of more for the t-table. We kind of use the word slope. Again, that's how much it's changing vertically versus horizontally, the rise over the run. And the start value is our y-intercept. We always start on the y-axis because that's where x is equal to 0 on the y-axis. All right, go ahead and write these down if you haven't already started to do so. And on the right, you should see this on your right. Rate of change of a line is equal to the slope m. That's the letter we use for slope. And the start of the line, where we start always when we graph a line, is the y-intercept in this method. If you need to pause this, go ahead and pause this. We're going to keep on going. All right, so how does this all work to help me graph in this new method I'm speaking of? So let's look at our equations. The main thing is when we graph a line, we have to make sure we're graphing it in the correct direction, whether it's increasing or decreasing. We just went over this. So we'd always look at our slope. So in this case, my slope is -3. It's next to the variable x in slope-intercept form, which tells me, decreasing because it's negative. It's going down. And again, when we're talking about increase, decrease, we're looking from the left side to the right side, not from right to left. So this is decreasing because my slope is negative. It's going down 3 every one. So again, we're going down 3 as we go to the right. Again, we're rising down as we run to the right. And my y-intercept is 7. Next one, my slope, I only see one number written down here. But remember, if there's no number next to a variable, that number is always a 1. So in this case, my slope is the number 1. It's positive, which tells me that I'm going to be increasing in this line. I'm going to be going up 1 over 1 as I rise to run. So 1, and my y-intercept is not 10, but -10. All right, let's move on to the next two. I want you guys to do them on your own. Pause the video if you have to, and then check your work. All right, you should have these done. You should have gotten increasing because positive 3/4 is our slope, and our y-intercept is 6. So 3/4, it goes up 3, runs 4. Next one, we have an increasing line. Again, our slope is 15 because it's next to the variable x in slope-intercept form. What is my b value? It's not there. If it's not there, it's the number 0. So we can add 0 to the end of that 15x, and we would not affect it. All right, let's go ahead and actually get to the actual graphing piece. Now that we know these two bits of information, this will help us graph something quickly. It's the same as doing a table, but it's actually a lot faster than doing the table. So we're going to go ahead and start looking at our equation. Just always ask yourself, am I going to have an increasing line or decreasing line from left to right? In this case, decreasing because we have a -1 in front of the x. That's not written down. So we have -1 and 3. So we always start at the b value, which is our y-intercept, always on the y-axis. It starts at 3. So we're going to put a point at 3. That's going to be my starting point. Remember, on the t-table, the b value is always a 0 value with x. And from here, my m is -1, which means I'm going to be going down 1 as I move over 1. So I'm going to make the first number into a fraction. I'm going to divide it by 1. And the first number is going to be the rise, and the second number is going to be the run. So I'm going to rise -1, so I'm going to drop 1 and go over 1. So that's where this point comes from. So I'm going to go down 1, over 1. So that's kind of that general idea. We're going to go down 1 and over 1. And we're going to go down 1 again and over 1 again. And we're going to put our next point right there. And we're going to keep repeating this process down 1 over 1 until we run out of space on the grid. And then we can always go backwards, up and back, up and back, up and back. So this pretty much gives us what our line should look like based off this slope right here, which says down 1 over 1. So rise over run. And then from there, you just go ahead and connect your points. There are some nicer ones. And we are done with our graph. So again, start at 3, y-intercept, and then the slope tells you which directions to follow to get the rest of the line. It should not line up perfectly if you do it correctly. Second, number 2, we know this is decreasing because we have negative 2/3 as our slope, and we have negative 4 as our y-intercept. We're going to start at negative 4 on the y-axis. Main thing is, remember, always start on the y-axis. The intercept is a slope-intercept for the y-intercept. Now in this case, my slope is negative 2 over 3. Again, we're decreasing still. So I'm going to go down negative 2, and then I'm going to run 3. So for every vertical move down 2, we run 3. So we're going to go down 2, and we're going to go over 3. So that's where we end up. So down 2 over 3. So we're going to go down 2 over 3. And again, always go backwards to get a nice, correctly graphed line. I'm going to go backwards, up and back 3. And that's going to give me my next point, which goes right here. And then we can do it one more time, up and back 3. And that leaves me right here on the x-axis. And then we go ahead and connect our points. And we have a perfectly graphed line without needing a t-table. All right, next problem. We're going to go ahead and graph this one. We have, this line has 1/2 as its slope. So that means it's increasing. And that means it's 1/2. And my y-intercept, there's nothing added to the end, so nothing represents 0. Which means we're going to start at 0 on the y-axis, which actually ends up being our origin. And from there, we're going to rise 1 and run 2. So we're going to rise 1 and run 2. Rise 1, run 2, and we can do it one more time. And then we're going to go backwards, same thing. Back down 1, backwards to the left 2. And then we get all our points that way. And connect it when we're done. Let's go ahead and move on to the next one. Pause it if you still need more time. I want you to try this one out on your own, and then come back when you're done and check your answer. You should have put that this line is decreasing. Slope is negative 2. Y-intercept is negative 5. Let's make our slope into a fraction after we graph our point at the y-intercept at negative 5. So we have to go downwards because it's a decreasing line. So that means down 2 over 1. And this one ends up off the grid, and that's okay. So that's why we want to go backwards to get a better sense of the line. So up 2, back 1, up 2, back 1, and so on until we run out of room and we connect our line. All right, let's check the next one. Same thing, I want you to try 5 and 6. Again, pause the video and we'll come back and check our work. So this next one, you should have gotten negative 1/5 as your slope. 6, and make sure you circle decreasing. I don't think it's not showing up on the video. I think the graph covered it up, so it should be decreasing. So make sure you circle decreasing. We start at 6. We go down 1 and run 5. Down 1, run 5. We can go one backwards. It's not going to be too difficult. It's going to be off the grid. So we go backwards 1. Just to see it, it should be right there. Right? Up, and we go up and back. So that gives us a general idea of what it should look like. And the last one, let's check your work. Let's start at 3, and we're going to rise 3, run 2, because this is an increasing line. Slope is 3/2, y-intercept is 3. We start at 3, up 3 over 2, and then backwards, down 3, back 2. We can fit a few points, and then we connect them off. And we're done graphing these. Now, just one more thing I want to get into that I see some students make a mistake on, so make sure you follow along on this next little piece, even though you don't write it down. What if the point goes off the graph? Like, what if it goes off the graph more than one little space or 2? What if it goes significantly off the graph from the start? So, for example, what if I wanted to graph this one, and I'm going to start at negative 4, which means I start right here. And then I have my y-intercept, my slope of down 5 over 3. So if I try to go down 5 over 3 here, it's going to be 1, 2, 3, 4. It's way off the grid. I kind of ran out of space here based off this graph. You can still kind of estimate that it's going to be down there somewhere. But let's say this number was even bigger than 5. What if it was a 7? Just go in reverse from the start. I can just go, instead of down 5, I'm going to go up 5. 1, 2, 3, 4, 5. And back 3. 1, 2, 3. If you just go in reverse, you'll have your line just the same way. 1, 2, 3, 4, 5. 1, 2, 3. So you'll still get your line either way. Just go backwards from the start. If going the regular way, it goes way off the grid. So it still works out. Don't freak out. It still works. All right, go ahead and make sure you start working on your other assignment, and good luck.